Last week, at the World Artificial Intelligence Conference in Shanghai, a man missing his left hand put on an EEEG headset. He thought about a handshake. A robotic hand did it for him. No button, no joystick, not one spoken word, just a headset, a stream of electricity, and a machine that moved because he wanted it to. This video explores the rapid advancements in Chinese robots, brainwaves, and physical AI, and whether your brain is genuinely becoming the next control layer for robots. And the real answer is far stranger than mind control. Because what actually happened underneath that headset has nothing to do with reading a mind. It has to do with something far more mechanical and far more interesting. So, what was actually happening in that headset? You are watching the Tech Tales series? Take a second, subscribe to this channel, and let's get into it. Every brain computer interface, no matter how futuristic it looks, runs on exactly three steps: signal detection, AI decoding, action execution. That's it. Electrodes pick up electrical noise. A model turns that noise into a guess about what you intended. A machine executes the guess. Everything else is marketing. So, where does the real technology live in that chain? Here's the fact that makes this less magical and more industrial. The most advanced version of this isn't a headset at all, it's a robot. Neuralink, the company Elon Musk founded in 2016, builds a surgical robot that threads electrodes thinner than a human hair directly into cortical tissue, up to 1,024 of them per implant. And by late last year, 12 people worldwide were already living with one of these threads inside their skull, using them to move a cursor, browse a phone, play a video game with nothing but intention. So, what happens when you put that next to what most of us picture when we hear brain computer interface? One reads electricity through a skull, filtered, attenuated, blurred by bone and scalp. The other reads it at the source, sitting directly on neurons. Same category of device. Wildly different fidelity? Why does that gap matter? None of this started last week either. It traces back to Defense Advanced Research Projects Agency funded research in the 1970s, through the Brain Gate trials in 2004, through a monkey playing Pong with its mind in 2021, through the first human implant in 2024, all the way to a demo stage in Shanghai a few days ago. This has been compounding quietly for 50 years. It just picked a very loud week to go mainstream. None of it works without an AI model sitting in the middle of the pipeline. Raw neural signals are chaos, spikes, noise, crosstalk between neurons that have nothing to do with each other. A transformer model, the same architecture behind the last decade of generative AI, is what turns that chaos into a clean prediction: reach, grasp, release. Without that model, you just have a very expensive way to record static. Here's the part almost nobody selling this technology says out loud. That wristband some of you are wearing right now, the one paired with smart glasses, isn't reading your thoughts. It's reading your muscles. Meta's neural band, which came out of its 2019 acquisition of a startup called Control Labs, uses electromyography, the electrical signal your motor neurons send to your hand before your hand even finishes moving. That's a genuinely different technology than a brain implant. It just gets marketed with the same word, neural. Does that distinction matter? You'll see this message a lot if you go read the accuracy literature instead of the press release. Researchers Ann Wexler and Robert Thibault have spent years pushing back on consumer EEG claims, and independent testing backs them up. One review found that the cheapest consumer headset on the market, tested against a research grade device, scored an accuracy of 31%. That's barely better than guessing. A lot of what gets sold to you as reading your brain is closer to reading your eyebrows. So here's the reframe nobody in this space is making out loud. The bottleneck was never really the interface. It was never really about finding a cleaner way to talk to a robot. The bottleneck the entire time has been what the robot has to learn from in the first place. Physical AI doesn't run out of compute first. It runs out of real world movement data. Millions of hours of a hand grasping a cup, a wrist rotating, a knee absorbing weight, data the internet never recorded because nobody films their own hands doing chores. Where is all of that data supposed to come from? That's why a company like BrainCo isn't really selling a mind controlled arm. It's selling something quieter and more valuable, a way to harvest human intention and movement second by second and turn it into exactly the training data a robot needs to learn to move like a person. The headset was never the product. The dataset was. Here's the number that explains why every major chipmaker suddenly cares about neuroscience. Nvidia's Jensen Huang has called this the ChatGPT moment for physical AI, the point where machines start acting in the real world instead of just answering questions in a chat window. He's also put a jaw dropping figure on what's at stake $40 trillion, his estimate for the size of the humanoid labor market. When a number gets that large, everyone with a sensor to sell starts calling it neural. And this is where it stops being their story and starts being yours. That watch on your wrist, those earbuds, that keyboard under your fingers right now, they are already logging the exact category of signal that Shanghai crowd was so impressed to see decoded on a stage, just slower, cruder, and with your consent buried in a terms of service update you never read. What do you think that data is training? The single most important idea this video has now proven is this. Brain computer interfaces were never being built primarily to give you a new way to control a machine. They were being built to solve AI's real shortage, the shortage of embodied, physical, moment by moment human data, and mind control was simply the demo that got people to volunteer it willingly. The surface story was a robotic arm grasping a cup. The story underneath it was your body quietly becoming the training set for whatever moves next. If you made it this far, you tick the CAPTCHA checkbox. You're not a robot. Subscribe and see you in the next one.